Good morning, all of you. We have seen the different properties of acids. Acids are sour in taste. They change blue litmus red. They contain H plus ions. They react with metal to form salt and hydrogen. They react with carbonates or bicarbonates to form salt, water, and carbon dioxide. Now let's see another property of acid, that is reaction with base. Acids react with bases to form salt and water. This is a property of base also. Bases can react with acid to form salt and water. Let's see that reaction. Acid plus base. Acids can react with bases to form salt and water. This is another property of acid, or we can say this is another property of base also. For example, HCl. HCl aqueous means in water we are making an HCl solution. That is what is meant by aqueous solution. Then base, that is NaOH. Again in the dissolved format in water, dissolved in water, and we get NaCl salt. The salt is again we are writing aqueous only because in presence of this water you will not be able to see solid salt. It is in the dissolved condition. So you can write acid plus base gives salt and water. This reaction is known as neutralization reaction. Acid, base, neutralized. What is neutralized here? Acid and base neutralized each other, and here water is neutral, and the salt is also together. Altogether it is neutral. Next property, reaction of metallic oxides. Reaction of metallic oxides with acid. Metallic oxide. What is meant by metallic oxide? Oxide of a metal. Oxide of a metal, that is, this calcium is a metal, sodium is a metal, so its oxide is metallic oxide. Calcium oxide, sodium oxide, these are basic in nature. Metallic oxides are basic in nature. Basic in nature. So our acid can react with these things. Calcium oxide can react with an acid. Copper oxide. See, copper is a metal, its oxide is metallic oxide, that is copper oxide, basic oxide. So, calcium oxide, basic, Na2O, metallic oxide, basic, CuO, that is metallic oxide, basic. So, these things are basic, they can react with acid. They can react with acid. So, this is base and that is acid. So you will be getting what? Salt and water. Let's see one reaction. For example, copper oxide. Copper oxide, you know, that is black in color. In first chapter, you learned copper oxide oxidation reduction reaction. When you learned, you saw that copper oxide is black in color. Take small amount of this copper oxide in a beaker and add dilute hydrochloric acid. So you take a beaker and you add dilute hydrochloric acid, and to that you add a little bit of copper oxide, metallic oxide. Note the color of the solution. You will notice that the color of the solution becomes blue green. The color of the solution becomes blue green. Color of the solution becomes blue green. And the copper oxide dissolves. Blue-green color of the solution is due to the formation of copper chloride. So CuCl2. Blue-green solution is due to the formation of copper chloride. That means that is the salt form. So general equation you can write in this format, that is metal oxide. Metal oxide plus acid. Metal oxide is basic. Metallic oxides are basic nature. So what is formed? That is salt and water. Salt and water. So this is again an example for neutralization reaction only. Metallic oxides are basic in nature. Then what about non-metallic oxide? Let's see the non-metallic oxides. Non-metal, for example, carbon. Non-metallic oxide, carbon dioxide, it is acidic in nature. Acidic in nature. When you dissolve this carbon dioxide in water, you will be getting an acid. Carbon dioxide is acidic. So, how can we prove that it is acidic? You react it with base, for example, calcium hydroxide. Calcium hydroxide is a base. We know that when carbon dioxide is passed through calcium hydroxide, you got salt, white precipitate of calcium carbonate, and water. Means lime water turned milky. This we have seen, lime water. Calcium hydroxide is called lime water. So carbon dioxide, this is non-metallic oxide. Non-metallic oxide. This is non-metallic oxide. When reacted with base, we are getting salt and water. Means acid plus base gives salt and water. So reaction of a non-metallic oxide with base, what happened? Salt and water. This is similar to acid-base reaction. Acid plus base or base plus acid. Acid plus base gives salt and water. This reaction is called what? Neutralization reaction. Now let's see some questions. I'm taking page number 22 for the questions. That is question number 1. Why should curd and sour substances not be kept in brass or aluminium vessels? Brass vessel. Brass is copper and zinc. It is an alloy of copper and zinc. So these metals will be reacting with acid to form salt and hydrogen. We know that metal plus acid gives salt and hydrogen. So what happens? This curd is acidic. So when curd is kept inside this metallic vessels, the reaction will be taking place. Metal will get spoiled, that vessel will get spoiled, plus this curd becomes toxic. So curd or sour substances, SOUR, sour means acidic substances, should not be kept in metallic vessels because generally metal will be reacting with acid to form salt and hydrogen. That vessel will get spoiled and curd becomes toxic. Question number 2 from that box given in page number 22. Which gas is usually liberated when an acid reacts with a metal? We know that which gas is liberated. This is hydrogen gas is liberated. Illustrate with an example. You remember that soap solution, uh, that hydrogen gas is passed through this soap solution. Hydrogen gas is passed through the soap solution. So the bubbles which are coming out will be coated with soap solution, a film of soap solution. So in that globule, in that bubble, hydrogen gas is there. When you bring a lighted candle to that will be burning, hydrogen gas will be burning with a pop sound. How will you test for the presence of the gas? What you have to say? You have to bring a lighted candle to this bubbles. The bubbles will be burning with a or bursting with a pop sound. Next question. Metal compound A reacts with dilute hydrochloric acid. Next question. Metal compound A reacts with dilute HCl to produce effervescence. Effervescence, what is meant by effervescence? When you open a Pepsi bottle or Coca-Cola bottle or a soft drink bottle, carbon dioxide gas rushes out. That rushing out with so many bubbles is called effervescence. So many gas bubbles will be rushing out, giving the drink a sparkle. So that is for an appeal. That is for the presence, how they are presenting that soft drink. So when you open this bottle, carbon dioxide gas rushes out. That is called brisk effervescence. The gas evolved extinguishes the burning candle, so that means it is carbon dioxide only. Write a balanced chemical equation for the reaction if one of the compound formed is calcium chloride. If one of the compound formed here as a product, that is calcium chloride. So what is A? Then we are going back to see what should be A. What should be A? That should be calcium carbonate. Calcium carbonate. Calcium carbonate plus HCl gives carbon dioxide plus CaCl2, and we know that water is also produced. So salt water, this is the salt water and carbon dioxide. So this is the equation. Write the balanced chemical equation. Carbon 1, then calcium 1, calcium 1, carbon 1, then oxygen, 3 oxygens here, 3 oxygens here. So here 2 oxygen and 1 oxygen, so that is also balanced. 2 hydrogens here, there are also 2 hydrogens. 2 chlorines here, there are also 2 chlorines. So the equation is balanced. Next topic what we are going to see is what do acids and what do all acids and all bases have in common? What do all acids and all bases have in common? Let's see with an experiment. Actually, they are having ions. IONS, ions or ions. IONS, maybe positive ions or negative ions. If it is HCl, then they have H plus ions and Cl minus ion. When dissolved in water, these ions are free to move. Free to move means they can carry, on moving means they can carry electricity. What do this base NaOH when dissolved in water, that is Na plus and OH minus, they get separated. That means again ions only. So acids and bases are having ions in common. Acids are having H plus ions in common. Bases are having OH minus ions in common. Let's see how this is explained. Look at this experiment. Here, an iron nail, another iron nail, they are connected through this wire. One battery, 6-volt battery is fitted, bulb is fitted, switch is there, and another wire. And these nails are not touching. That means circuit is incomplete. You are putting circuit is incomplete means bulb will not glue. After that, you are putting this solution, dilute HCl solution, bulb will glue. Before putting this dilute HCl solution, bulb will not glue because the circuit is incomplete. This is a rubber cork. Rubber cork will not conduct electricity, will not carry current. So circuit is incomplete. This iron nail is not touching this iron nail, and between them is rubber cork. Rubber cork is an insulator. Current will not flow. The circuit is opened. Now to that you are adding, that is uh, when this after switching on the after putting this switch on, then also the bulb will not glow because the circuit is incomplete. To that we are adding dilute HCl solution. Now the bulb will glow. when you switch on this, when you put this connected, when you switch on this, when you put the switch on. Now, after putting this dilute HCl, you will see that the bulb will glow because dilute HCl solution has so many H plus ions, so many H plus ions and Cl minus ion. So, due to the presence or due to the movement of these H plus and Cl minus ion, means H plus ions carry current, Cl minus ions also carry current. So they have ions. So the solution is having ions. So these ions can carry current between these iron nails. So the circuit is complete. So this acid is having ions. These ions will be carrying current and the circuit is complete and the bulb will be glowing. You can consider another acid HCl, HNO3. HNO3. So HNO3 gives H plus and NO3 minus ions. These ions carry current. If it is H2SO4, H2SO4, H plus, how many H plus? 2 H plus and SO4, 2 minus. Here also they have ions. These ions are capable of carrying current. So the circuit will be completed, the bulb will glow. So HNO3, H2SO4. Another example, acetic acid, CH3COOH. On dissolving in water, CH3COOH can produce CH3COO minus and H plus and H plus. So acids when dissolved in water produce ions. These ions are capable of carrying the current and the circuit will be completed, bulb will glow. Repeat the same activity using alkalis such as sodium hydroxide, calcium hydroxide, etc. Again, the bulb will glow. These are also having ions. So, acids and bases are having ions in common. If it is acid, for example, HCl, H plus and Cl minus ion, HNO3. If it is nitric acid, then H plus and NO3 minus. If it is sulfuric acid, then 2H plus and SO4 2 minus. If it is acetic acid, CH3COO minus and H plus. So, acids are having ions. You, you can do this experiment with bases also. NaOH, NaOH. So Na plus and OH minus in aqueous solution, they can produce free Na plus and OH minus ions. These Na plus and OH minus ions can carry electricity. They can carry current and the circuit will be completed. KOH, KOH when dissolved in water, K plus and OH minus will be separated. They are free to carry current. Or calcium hydroxide when dissolved in water, you can get Ca2 plus and OH minus, twice OH minus. So they can carry current. So acids and bases have ions in common. Acids are having H plus ions in common. Bases are having OH minus ions in common. So we have seen that whether it is acid solution or base solution, the bulb will glow. But if you do this experiment with sugar solution, the bulb will not glow because the sugar solution cannot produce ions. Sugar solution cannot produce ions. Or if you take alcohol instead of this dilute HCl, if you take alcohol in that or glucose solution or alcohol, the bulb will not glow. If it is acidic solution or basic solution, the bulb will be glowing. Or instead of this acidic or basic solution, instead of this acidic solution or basic solution, if you are putting glucose solution, bulb will not glow. If you are putting alcohol solution, the bulb will not glow. If you are putting sugar solution, the bulb will not glow because they cannot produce ions. They cannot produce ions in aqueous solution. So in aqueous solution, ions carry current. In aqueous solutions, ions carry current. So glucose solution and alcohol solutions do not conduct electricity. Sugar solution cannot conduct electricity. Alcohol solution cannot conduct electricity. Glucose solution cannot conduct electricity because they cannot produce ions. The electric current is carried through acidic solution or basic solutions by ions. Now, next topic is what happens to an acid or a base in a water solution. What happens to acid? First, let's see what happens to what happens to an acid. What happens to an acid? After that, we'll see what happens to a base in water solution. Acid, you know that acid can produce H plus ion. In water solution, this H plus ion will be formed, will be combining with H2O to form H3O plus. In water solution, see in water solution, acid will form hydronium ion. Hydronium, hydronium ion. Because H plus cannot exist on its own. Hydrogen ions cannot exist alone. Hydrogen ions cannot exist alone, but they exist after combining with this water. When we, but they exist after combining with water molecules. Thus, hydrogen ions must always be shown as H plus aqueous or H3O plus. So H plus ions, either you have to show like this or you have to show like this. This is called hydronium ion. This is called hydronium ion. So acids, what happens to an acid in water solution? What happens to an acid in water solution? The produced H plus, the produced, you know that water can separate this H plus and Cl minus, and that H plus ions will be combining with water molecules to form hydronium ion. So an acid can show its property only in presence of water, only in presence of water. So what happens to an acid in a water solution? What happens to acid in water solution? In water. Let's see with an experiment. So in this first test tube, in this test tube, we have taken sodium chloride. To that, we are adding concentrated H2SO4. HCl gas will be produced. You see, preparation of HCl gas. So, HCl gas will be produced. If you are closing it with a cork, with a hole through which a delivery tube is connected, then this HCl gas will be coming through this. HCl gas will be coming through this. Now, if you are putting a litmus paper here, blue litmus will not turn to red. It will not turn to red because this is dry HCl. The gas produced is dry HCl. Only wet HCl can produce H plus ions. Only wet HCl can produce, only wet HCl can change this blue litmus to red. Now, since the gas is dry HCl, since the gas is dry HCl, this HCl, hydrogen chloride gas, HCl gas, this HCl gas will not change blue litmus red. But if the atmosphere contains moisture, then this dry HCl become wet HCl. That means in presence of moisture, this will produce H plus ions and the blue litmus will be turning to red. If the climate is very humid, then you will have to pass the gas, hydrogen chloride gas produced through a guard tube. This is a guard tube. So a guard tube, this guard tube can be connected over here so that the HCl produced will be passed through this guard tube, and the in that outcoming HCl gas will be dry. If that HCl gas is wet, if suppose the HCl gas is coming and the atmosphere is having moisture, so blue litmus will turn to red. So, if the atmosphere or if the climate is very humid, means it contains moisture, then you will have to pass the gas. You will have to pass the gas through a guard tube. A guard tube. Guard tube means that contains calcium chloride. It can absorb all the moisture. It can absorb all the moisture from dry HCl. If HCl is dry, then blue litmus paper will not turn to red. If HCl is wet, then the blue litmus paper will turn to red. So, what can we show that HCl can act as an acid? It can show the properties of an acid only in the presence of water, only in the presence of moisture. So, only in the presence of moisture, HCl can produce that H plus ions only in the presence of water. So, what happens to an acid in a water solution? This H plus formed will be combining with water molecules to form H3O plus. So, it is actually you have to write it as H3O plus Cl minus, or you can write H plus aqueous. H plus cannot exist on its own, so it always combines with H2O to form H3O plus, that is called hydronium ion. So my point is, dry HCl cannot show the property of acid. Only the wet HCl can produce H plus ions. That means it shows the properties of acids. So HCl can show its property only in the presence of, or HCl can produce H plus ions only in the presence of water. Now, similar is the case with sodium hydroxide or bases. So sodium hydroxide, NaOH, NaOH, H2O. NaOH H2O, then Na plus aqueous means in water plus OH minus aqueous. So in presence of water, NaOH also splits into ions, Na plus and OH minus ions. So in presence of water, a base produces OH minus ions. Another basis, KOH. KOH in presence of water. KOH in presence of water, that is K plus aqueous and OH minus aqueous. Or another base, that is MgOH twice. MgOH twice. These are solids. When you put in water, H2O, then Mg2 plus twice OH minus. So these are in aqueous. So only in presence of water, this dissociation, this breaking, this ionization takes place. Only in presence of water, this ionization means water has the capacity to detach them apart, to dissociate them, to ionize them, to break them apart. So let's see. Once again, you can take different acids, and for example, HCl plus H2O giving H3O plus, H3O plus aqueous plus Cl minus, or H2SO4 plus H2O giving H3O plus. These twice H3O plus SO4 2 minus. HNO3 plus H2O gives H3O plus NO3 minus. So what is common in them? Means H plus ions are common in acid. H plus ions are common. Now what about the bases? What about the bases? So these are acids. Acids in water produces this hydronium ion. Acids in water produces hydronium ion. And bases. Bases in water, NaOH in water produces Na plus and OH minus. So here we will be writing aqueous. This is solid, or KOH, solid in presence of water to form K plus aqueous and OH minus aqueous, or MgOH twice. This is base, solid in presence of water. You can write Mg2 plus aqueous plus OH minus, twice OH minus aqueous. Now, if you put an acid and a base, then what will happen? What will happen? This will combine with this. That is, here H plus ions will be combining with OH minus ion to form water, and the remaining will be combining with, this is NaCl, salt plus salt, NaCl and water, and salt plus water. So that reaction is called neutralization reaction. Neutralization reaction. Thank you.